Hey, Georgios, and Georgios is pronounced correctly or perfectly?
Hey, yeah, that's pretty good. That's pretty good, to be honest. Well, it translates to George,
Yeah.
and so it, just use George. It's way easier. I mean, Greek names are too hard to pronounce
Oh,
mostly.
how Greek would pronounce Georgios?
It'd be Georgios.
Georgios?
Yeah, it's
Ye-
tough.
no, Georgios. Is it correct or not that correct?
No, that's almost perfect. Yeah, that's almost
Almost.
perfect.
Georgios.
Yeah, it's Georgios.
Georgios. Georgios. I thought I'm.
No, that's
Oh, perfect.
perfect.
Yeah. So you see, I'm old Greek. This is why it works. So what was your first computer?
First computer. If I remember correctly, it was probably NTM2 350 megahertz. I think this was like probably 1998. I think my parents
Hmm.
got my brother and I a first computer. Yeah. So yeah, we were nagging them about it for a while. Like, oh, we want a computer, we want a computer. Obviously to play games. So yeah, no, Pentium 2 350 was pretty good back then. I mean, 450 was like the best you could get. But 350 was pretty powerful. But like if you compare it with the specs today, it's great. It was like 32 megabyte of RAM, maybe like 650, 640 megabyte hard drive. So yeah, it was crazy compared to what you have today.
Yeah. And what you played? Quake, I assume.
No, actually, I never liked first person shooter games. I know Quake yeah, was all the rage, but no, I was more into like Age of Empires,
Oh.
StarCraft.
Hmm.
Yeah, so and some of the racing games. Yeah, so that was fun.
So Age of Empires also lost some time with it. I
That's,
remember. So I really liked
you,
that. So it was like, yeah, yeah.
yeah, I love the Age of Empires. Yeah, we spent a lot of time on that one.
Hmm. And how you start to code? I mean, you just play games, or what was the transition to scripting, coding, or whatever you had to do?
Yeah, so this is interesting. Actually, I although I was like super interested in computers from like I don't know, probably like ninth grade, eighth, ninth grade, something like that. I actually never got into coding on my own, right? So
Hmm.
I didn't have any like older mentors or anything to help me out with this. So actually, I never got into coding on my own. What I really followed back then was like the hardware stuff. So I knew like all the hardware specs and all the stuff that were coming up and like weird stuff like that. But I never actually like did any scripting or anything until I got to university, right? So in back
Hmm.
then, so I don't know what the situation is now in schools, but back then in schools in Greece, like we had like a computer science, let's say, class, but it was like totally theoretical, right? So you would write like algorithms on paper. So that's like really stupid, I would say.
Hmm.
So yeah, I never did any real programming until I got to college, right? When I went to college, I knew I wanted to do computer related stuff. Back then, I thought I would wanted to do computer hardware and stuff like that. Um, but no, I actually started coding in university. So like when I was like 18, 19, something like that. I know like a lot of people in our industry, like they code when they're 12 or 13 or stuff like that, but that was not me for sure.
So you were worse. You were no worse. Forced to code then at the university, more or less, right?
Forced, well, it was something I wanted to do. So I got good grades and
Okay.
everything. So I could get into whatever school I wanted pretty much. But I wanted something like computer science, engineering oriented. So I went there and I knew I wanted to do something with computers. So yeah, but once I got there, I mean, I found a lot of like-minded people and stuff like that. So that's when we really like uh, forced each other. I mean, I guess to
Inspired each other, right?
yeah, exactly. Learn new stuff, try new
Mhm.
stuff, things like that. Yeah.
I think it doesn't matter when you start coding because no, the only important thing is to be passionate about that. And if you're passionate in shortest amount of time, you can actually be productive and then take some time, to learn about all the errors can happen. This is the challenge that you know your environment well enough that if this error happen, you know what to do. But
Absolutely.
yeah. So if you're passionate, just no problem at all. So, which was the first language?
First language. So this is like kind of embarrassing to be honest, because this was like like one of, if not the top, like computer engineering schools in Greece. and the first course was like in Pascal, right? And this was in mid 2000s. So even by then, Pascal was like way out of date. But we had like the professor who's like, I think he was part of Pascal's the Nicholas Wirth's team at one point. So he was really into Pascal. So we had that. But
this is not bad. I mean, why? I mean, Pascal is the absolute foundation. I would say Visual Basic would be worse, right? But Pascal, I mean,
absolutely.
Pascal is nothing wrong with Pascal, I would say.
No, there's not anything wrong per se, but I would say it's good to teach you like the basics, but there's like no chance you're ever going to use anything remotely close to Pascal in real life, right?
But Delphi, right? In 2000, you could get a Delphi project that was similar to Pascal, right?
I guess back then. Yeah. So we did Pascal, yeah, and then like second course was in C, right? So that was
okay.
Yeah, that's when people's minds really started to explode with pointers.
Yeah, this is what I was.
Stuff.
Yeah, pointers and dereferencing. That this is also fun for me, to understand. This was like.
Yeah, exactly.
And you enjoyed both Pascal and C, or?
No, I loved it. I mean, that was like the first time in practice where I could actually like manipulate computers, right? To do what you kind of wanted them to do. I mean, sure, at that age, you in that point in your studies, you can do very basic stuff. You can't do anything like really awesome, but that's when you can start to see like, wow, this is really, really powerful.
Mm-hmm. Okay, and what happened then? So you start coding for joy or just for assignment? So where I'm going with it. So what you did at university may be interesting beyond the assignments, and what happened? Mm-hmm.
Right. So I wouldn't say that I coded for my own stuff, because like university studies, if you really wanted to do good, it took up pretty much basically all of your time, right? So this was an electrical and computer engineering degree, which meant that you had a lot of other like math and physics and weird stuff like that. So you had to put in a lot of time into stuff that you didn't necessarily love that much. So I really started coding a lot, let's say my third year, when we started switching to like majors where you're like getting into like advanced courses like operating systems and compilers and stuff like that. But I would say when things really took off for me was in my third year. So I should take a step back. In Greece, a lot of the times you have like student protests, let's call them, and they take over the university and they shut down the university, right? That happens. That happens fairly often. So when I was in my
is it like tradition, or is it a true protest to achieve something?
Well, there's always something they want to achieve, but it's usually like a protest to like a reform the government wants to pass with relation to higher level education, stuff like that.
Okay.
So I can't remember exactly what it was back then, but yeah, it was something like this. And the result was that university was shut from from Christmas time until like spring break. So it was like 3 months.
Wow.
No classes or anything like that. So what I did at that point was I stumbled upon, I don't remember exactly how, on Java How to Program. I think this was like the 5th edition or 6th edition or something like that. And that had some really cool stuff in it, right? It had some really cool examples of how to do swing and like interactive databases and stuff like that. So that's when I really started to program and do a lot of extras for assignments, university assignments. Like university assignments say do like this part, and then we would go ahead and do 3 times more because we just enjoyed it so much.
Mm-hmm. So this would be a good strategy at Red Hat, right? You can create a protest because of something, and then you have 3 months time to go, to do the cooler stuff, and then you come back and say, hey, look, we did this, right?
Yeah, exactly.
This is a good strategy.
For me, that turned out pretty well because we had a lot of time to do some cool stuff.
So, and why you like Java? So, because you knew C and Pascal. So, why you like Java back then? So, what's it's interesting because Java 5 is a pretty advanced. So, it was like 2005, right? Almost.
Yeah. So we were lucky that at that point. So I think one or two of the classes, like when we then switched to major, which was like from the fifth or sixth semester on, a lot of the classes, like I said, were more advanced, and a couple of them had they weren't exactly explicitly teaching Java, but they were telling you, okay, like this is a database course, but the project you need to implement is like in Java. We're not going to teach you Java, but you have to write the
Okay.
application anyway. So what I started learning it, and then what I partly because of the book was so cool that I saw that you could like do like real world stuff super easily. Like back then I really thought that Swing was like amazingly cool. Like I could create graphic user interfaces so easily, and this was awesome. And this was contrast at the same time we were doing a compilers course, right?
Mm-hmm.
And at that course we were using C, and just to do anything was just like so hard. Like we did really well in the project, but we just had to slog through everything and see like we had to like create our own lists and everything. Like string parsing was just so hard. And in Java, all this stuff like just
I
existed.
remember in C there were no strings, right? String was a character array terminated by 0 or something like that.
Yeah, by the 0. So everything was just so hard in C.
Mm-hmm.
So in Java you could just do so like you could sit down, learn from a book, and in a couple like afternoons, you could have this cool graphic user interface that actually did some real world thing. And I thought that, wow, this is awesome.
Do you remember the name of the book?
Yeah, it was in Java How to Program from Detour, I think, and I think it was like 5th or 6th edition. I think it still exists, Java How to Program. Yeah, it was like a super thick book, like more than 1,000 pages, something like that.
Wow.
So yeah. Oh, and the other one, and there was also at the same time I think I was reading Bruce Eccles' book. I don't remember.
Thinking in Java. Thinking in Java. But it's Thinking in C++ and Thinking in Java from Bruce Eccles, exactly.
Yeah. Mm-hmm. So really cool stuff. Yeah.
So what you did, you implemented your first project was with Java was JDBC access to a database with I assume Swing frontend, right?
Yeah. Exactly.
Then I learned already a lot. I mean, then whatever you needed, right? You need to class loader, JDBC drivers, how they work, then Swing, how to fetch the data, results set to table conversion, table models, so all the concepts were there.
Yeah, so there's a lot of stuff that, like for the class loaders, like we just did class for name and didn't understand what it did, obviously, like at that point.
Yeah, but you still had to do it, right? So, I mean, you were exposed to the hard stuff, right? Exactly.
Yeah. But Swing, that's where I really enjoyed that. That's where I was like really trying to get the user interface like appear better with stuff which in these days I don't want to touch at all, but back then I thought it was awesome.
Yeah, and Swing was beautiful. Remember there were the Java 1 sessions, the extreme GUI makeover with Swing, where they started with something ugly and they just refactored it to be beautiful, and there were great Swing applications, and the last one is IntelliJ, right? It's also beautiful, and this is basically Swing or modified Swing, but still Swing. So you can have a really fast and beautiful UI with Swing.
Absolutely.
Okay. So what happened then? So this was the first step towards enterprise. So you had a Swing and your backend. Maybe this was Fat client, I guess, but it was. By the way. Back then, at the same time, I really liked what you did, the Fat clients, because with Fat clients, you can have a real object in Swing. So, if you have three tier applications, which were fine, but the problem was, the decoupling of the client with the backend. So you have to do a remote method invocation, whatever, and gather the data. So it was not always worth. So I was in some really successful projects where I did Fat clients without mentioned that they were Fat client because they were hated back then. So what I said, rich clients. This was the official name, but it was not all rich client. There was some term in between. There was a ultra thin client were the fat, and the rich client were flash like stuff on the clients. I used Java with direct JDBC connection, which was fine in enterprise. Behind the firewall back then was okay. Okay, so what is the next project? So you stick with Java then?
Yeah. So then Java became my go-to thing, right? So after that, we had some. Well, so at that point, actually, I should say that I had Java and C as my really strong things, right? Because
Yeah.
on the one hand, we did like the compilers and the advanced operating systems, so that was all uh, the advanced operating systems, for example, was developing simple kernel modules and stuff like that. So that was all really hardcore C. And on the other hand, you had the Java stuff. Which we had like a project where we were supposed to take a SIP client. SIP was that like some kind of voice over IP
Yeah,
thing?
session initiation protocol.
Yeah,
It was
exactly.
like a servlet, real-time servlet, where you had to know to call. It was very popular back then. So there were conferences talking just about SIP. I never understood that, because for me, none of my clients use SIP, but SIP was very popular. I remember. So this was like, everyone talk about SIP and real-time communications, and I say, yeah, but in enterprise, why you need, maybe if you're telco, and you're building your own telco controller, maybe it is interesting, but for other project not. But it was very popular. I remember SIP servlet, even there was a spec.
Wow. Yeah. So we had to in one project we had to upgrade a client. Well, take an existing application that was again the application and add some functionality on it. So again, that was a lot of Java there too. There's some of this other network programming stuff that all the examples were Java, because back then Java was the best, easiest way to do anything network related, right? Compared to Python stuff, C stuff is just light years ahead. So after that, basically, when I went to do my master's thesis, because this university was like a 5-year university, right? So there was no in between degree. You went straight to master's. But what I did is I thought, right, okay, when I go to get a real job, it's probably going to be Java. So I'll do the C stuff now, at university, because probably this is going to be my last chance to do C. Yeah. So I did some I don't remember, some Linux file system stuff, if I remember correctly. Yeah. And then I did went to transfer to another university when I finished, which basically was again a master's degree. So it just took a year. Then the same mix of stuff, basically, C and Java. Again, for my bachelor's thesis there, again, is this I took a C++ application, which was it was a computer architecture simulator or something like that, and fixed some things around there. So yeah, that was the end of my C++ days. Never touched it again since.
Okay. And what did you do with Java then? So you stick with Java. Master thesis was Java?
No, master thesis was C++.
Okay. And after that?
After that, okay. So here we have to add a little context. In Greece, you have mandatory military service for males, right? At that time, it was 9 months. Now I think it's 12. But anyway, so I was lucky enough, because I had computer science degrees anyway, that I was my military service was actually being part of a software development unit within the Army, right?
Wow.
Yeah. So the Army had this unit consisting of a few dozen people that wrote enterprise. Basically, it was enterprise software for the Army. So it was tracking of inventory, things like that. So I was on a project that actually did use Java, and at that time it was melodic, and a very early version of JPA or whatever. So I was actually able to use that before I actually even got a job. I was actually able to see Java Enterprise in action. The funny thing here is that it was a not really good way to see what things are in real life.
Yeah.
Because think about this scenario, right? You have people that come in, only stay for a few months, and then leave, right? And they have no real incentive of doing work, doing good work, because no matter whether you do good work or not, you're just going to get discharged anyway after a few months, right? So people would come in, write the most terrible code just to get things done, and then leave. So I saw things that are wow,
This is not that different to enterprise software. There are companies which hire external companies. They stay for 2 months and then go.
Yeah.
And there's a huge fluctuation among the developers. So it's very similar. Maybe it's a bit extreme in the army, but in real world,
very extreme. Yeah.
Yeah. I was unlucky then because I was also in the army, but I was 12 months. But this was the last year of 12 months. So the next season were 9 months.
Yeah.
So this was a little bit sad, and I was not allowed to touch computers in the army, and so double unlucky. But it was still a great time, but without absolutely offline. This was offline in the woods. Yeah.
Oh, okay. I only got like 2 or 3 weeks of that, and then it was all just like a real job, basically.
Yeah. And I get 12 months in the woods, and I saw once computer because someone used it to control vacations or whatever. So from
Oh, okay. Yeah. Well, when you get connected to talk to Dimitris again, Dimitris Andreades from Red Hat, who's my boss's boss, you talked to him a few weeks ago. But if you get a chance to talk to him, ask him about the what he did for the Navy, because he was stationed in the Navy. Ask him to tell you stories about the Navy and the computer systems they had there. So he has some pretty good stories.
Yeah, I already asked him. You listened to this?
Yeah, I listened to like the first half or so.
Yeah, first half. I think we have asking about the Navy and the computer, so we can go deeper. But it was also interesting. Is it your boss's boss?
Yeah, he's my boss. Yeah, he's my boss's boss. Yes.
Okay. So you have a nice boss's boss. So
no, Dimitris is great. No question.
Yeah. Yeah, perfect. So you built enterprise software, a chaotic one, and afterwards, after some confusion, you started in a proper company, which with Java or
right. So yeah, once I finished university, like next day, I started at a typical software house, right? So here in Greece, it was called at the time Intersoft International. And
Intersoft International, so double international.
Yeah,
Intersoft.
yeah, exactly. What they did basically, they took on a lot of European projects, right? So they had their flagship project was like a customs type thing. I was on some small project which tracked like EU grants or something like that for research grants. So at that point, this was 2011, I'm pretty sure. So the technology stack was, I think, so it was WebLogic. Can't remember the version. We were using EJB3 and JSF 1.2, and I think the Java version was probably 5. I don't think it was 6 at that point, but I could be mistaken. But what I really did not like about that was, two things basically. So WebLogic was super slow to start. So I would go in and to start my day, you booted WebLogic, took minutes to start, which was just crazy. And the other thing was the total disconnect between EJB and JSF. So they're like two different worlds completely. That you had to bridge somehow, right? And the third one was testing, right? Testing was just terrible back then, or at least the way we did. I'm like a junior software engineer, right? I had no real experience, so I'm following basically the lead of what the other people in the company were doing, and I did not like that experience at all at this point. The tech stack.
I like WebLogic back then, but I think you used the version 10. The version 8 was crazy fast, so it started. Under a minute for sure, but it was way faster. It was like single jar. It was very fast, and then it was since 8 it became more bloated and slower and slower. And EJBs were testable like a Pojos, right? So if you had the logic, you could test them. You could also test them via JNDI, but this was slow. So you could have unit tests, which calls, the EJBs. And there was even and I think it's called EGB container. So we can launch the container in the unit test, which I never did because the idea was to treat EGBs like POJO. So very like now in Quarkus request scoped was EGB the same testing strategy.
Right.
And JSF were a little bit harder to test, but we separated them. So usually, there was a JSF, then a backing bean, and the backing bean accessed the EGBs. So this was the architecture. Yeah. So what happened back then? And I used EGB3 a lot, but there were lots of exaggerated projects. I would say the technology was not as bad. The problem was crazy architects. So what I was, there were like 20 layers and lots of dependencies. So the extreme case, what I saw, the architect claimed they are lightweight because they use Tomcat, and I took a look at the war, and the war was either 50 megs or 500 megs. I don't even know, but it was orders of magnitude larger than the entire runtime. This was the stories from back then. So I think WebLogic, if you are reasonable, you could build decent stuff. And what was really slow was WebSphere back then. So regardless what you did, it was slow. But WebLogic, it really depend on the project whether it was slow or not. Okay, cool.
Got it.
So you didn't enjoy it that much because not testable, wrong architecture choices, right? And everything was slow.
Yeah. I mean, like you said, like I'm sure it could have been done better. But like in these types of settings, like everything had to be done quickly. Like the client needed the project yesterday, so yeah, you just chunk out code as fast as you can. You don't think about anything.
Yeah.
You just can't bother to improve stuff. Yeah. So basically, go ahead. Sorry.
So okay, so what happened then? You stick at the company, or you left the company, left the project, or what was the next big thing?
I left the company like after a year or something like that.
Okay.
Because like a new opportunity came up which was with the at the time the largest classified ads company in Greece. So they were running like a totally different stack. They were a lot more modern at the time. So I should probably say like the previous company, like we were using. So my first job, right? So the one with the JSF stuff, we were using like CVS. There was Ant, I think, is the build tool. So this is like really.
Well, CVS is tough. In 2011, at least Subversion was on the horizon, and I think
exactly.
Then, And I used back then Mercurial already. I think Mercurial I used, but as CVS is crazy. I think I never used CVS after 2000.
Yeah, exactly. That's my point. That stuff they were using outdated stuff even for back then, right? So, I'm not sure like how many people used Ant at the time. So there was Maven was definitely around, but I'm not sure how many people used it. So yeah, the second job, so at this classified ads place, was much more modern at the time. So it was Maven, some projects, some versions, some projects in Git. So they had like Jenkins for CI/CD. So basically, I thought, well, yeah, I'm gonna go to this place because they're a lot more modern, and at the very least, I'll learn like a lot more new stuff, basically, and hopefully see like a different style, not only of architecture, but of like trying of how other people build applications versus like what a software house would do, and just like copies one project to the next and then just moves on. Right?
So what you did then? So you had some stuff. What was WebLogic, JBoss?
So this is where things get interesting for me. So this shop is all Spring, right? All Spring. So they're using Spring at that point, like Spring 3.1 or whatever, and Tomcat, right? So immediately what I notice is like I come in and you see Tomcat, it starts in a few seconds, and I'm like, wow, this is so much better than WebLogic at the previous place where it took like minutes to start. Also, there was some swing stuff, so they did have some of the kind of like fat client thing you were talking about, not exactly like that, because it was implemented. Well, I guess when they started implementing this, which was way before I got there, this was like pretty new. So they were using JDBC and Swing probably since like the mid to late 90s. So that was pretty cool. When I went there, the swing stuff they were doing was pretty outdated, but they had moved a lot. Had started moving a lot to web, right? So you had like MVC style architectures, but it was all Spring based, right? So that's when I started using Spring. So it was like 2012, something like that. And at the time, like I thought that what I saw done with Spring and the way it was being used, at least at this place, was a lot better or easier to consume and granted me more velocity versus what the stack I was seeing like JSF and weird tests at the previous place. So I'm like, wow, this stuff is really this cool.
Was Spring XML configured or with annotation already?
Right, so they had started with Spring, so like the older products were all like XML and stuff, but okay. They had already started at this, they had started a sort of microservices type thing even at this point in 2012. They had like started to break out like new functionality. They would build it in like a new service, and this stuff would be in annotations, right? Mm-hmm. So yeah, this place was actually really forward looking at the time. So they had like new investors or something like that, and they had put in a lot of money, and so they brought like CTO from Criteo, I think. And they had like some really good engineers. Mm-hmm. So they were doing some great work. So I learned a lot, and I was basically. And the other thing that I really loved is that I had the ability to like make decisions, right, and own stuff versus like with the previous thing was just like the client needs this and we need to do it, we need to get it out, and this is the only way that the client will accept things, and you just have to do it, and that's it, right? So that made a huge difference as well.
So why you left the company then?
Why did I leave? So I stayed 2.5 years at this second job, I think. And at this point, like I'm still, what was I don't know, like 27, 28. I don't remember. So I'm like really, really like anxious to do new stuff, to figure out like how far I can go, things like that. So I switched to a company that was like a music streaming service at this point, but they were starting like a new department which was going to do like analytics and Android testing and stuff like that. So at that point, like there's only one person, my boss at the time, who was starting this new department, and he was going to hire some people, and I thought this was pretty exciting. So yeah, I jumped at that. And at this point, I kind of took like a detour because, well, first of all, we started doing Android testing. So that was like the first and only time I actually did like any Java stuff with Android. Right? I don't know how much Android you've done.
Was it still Java? The old Java, the Android Delvik, right?
Yeah, exactly. Mm-hmm. Yeah. So at this point, we're doing like we're doing testing for Android, which was pretty interesting because there's like a framework where you could essentially you could control the device from your own code. So we were writing some stuff like that to test Android, which is pretty interesting. That was one part, but the other part was we started like writing some analytics stuff in various stacks, right? So depending on what we wanted to do, we could be using like Node.js. That's when I started using Node.js, and then we could also be using like stream processing stuff like Apache Storm, right?
Ah, okay.
Yeah. So so this job, this is the third job. I'm doing like a lot of different stuff. So I Node.js, which I didn't say I loved. I thought it was. I mean, I don't know. I don't know how much Node.js you've done in your. I thought like I could obviously get stuff done, but I didn't really love it that much, right? But yeah, okay. I mean, the boss wanted to do some Node.js because he had read, I guess, the Node.js scales really, really well, and indeed it was really lightweight. Like things started in less than a second, and you can get stuff going really quick. So that was cool. But I didn't love the language. Like JavaScript, not for me for sure.
Yeah.
But the other stuff.
But what surprises me that you say Node.js scaled well, because Node.js was this is like reactive Quarkus with only one thread, right? So what if you would do it right with Quarkus, it should actually outperform Node, right?
Yeah, but Quarkus didn't exist back then, right?
No, but there were a similar technology like Grizzly. I don't know what you remember from. Grizzly was similar. It was like the engine of Glassfish behind the scenes, and the JBoss had Netty, right? So this would be the underlying and Vertex, I think, also exists, right? Back then?
Yeah, it did exist back then. Yeah, it did. That is true. Indeed, like I have no question. Like it was not like the best choice for scalability, but at that point, like I think people were very, at least the people I was hearing from, was that people were like tired of what they perceived as like unnecessary ceremony or in Java, stuff like that. So they wanted something more lightweight, something that they could like write very little code and get going immediately, right?
Yeah.
So I think that's what the appeal was for Node.js. Like I didn't see it necessarily that way, but I didn't think it was terrible either, right? Like I could live with like doing Node.js for a while. That was not a problem. But yeah, definitely these days, like no, I would not want to touch it for sure. Yeah, so Node.js on one side, and then the other side is like this data analytics stuff that we were doing.
With Storm, interesting choice.
Yeah, Apache Storm. Then we did some stuff from like Apache Spark. So yeah, there's like a mix match of a lot of different things in there at that point, right?
And wasn't the mix match not a problem in long term, because you need so many different technologies, so you need someone who knows everything, right? Or
well, that yes. See, so in retrospect, absolutely was a problem, right?
Okay.
When
because I never understood, Georgios. I never understood, on the conferences, like the polyglot is promoted and whatever, use the right, tool for the job. But this is a complete mess after a few years. So you won't find anyone who understands, half of the stack. So I don't even get why people are promoting the idea, actually, right?
I could not agree more, right? So
yeah,
this is the thing that at that point I'm like 29, 30, whatever. And I think like, the more stuff I can learn, the more stuff I can apply, the better. Absolutely. But like, if I were the team lead at this point, like, no, I would say like, no, you can't do that, because basically when I left, my boss had a problem. Like, there's no way we can it's hard to find somebody that can know like different things and fill in your spot. So no, I would definitely not do that at this point. Absolutely not.
I 2 years ago, I reviewed a project, and this was the most diverse project I ever saw. No kidding. There were like, I forgot how many, maybe 30 microservices. And first, there was no reason to have 30, right? They were just there because they liked the microservices. So the first idea was why we have 30, not 3. But no kidding. There was Node.js with JavaScript, Node.js with TypeScript. There was Quarkus, something Java, what I never saw, some Java framework. There was a Python, and the team was like 4 developers. And I asked them, why are you doing this? And they say, oh yeah, but microservices. And at the end of the day, they rewrote everything with Quarkus and are way happier. And I asked them, why you started with so many technologies? And they said they thought this is the way to go. But this is crazy, because, there was like a conference talk or whatever. They thought, okay, if we do this, we are faster because we can do this with Python, this with TypeScript, and this with JavaScript. But what they forgot, that they will have to maintain the thing as well. And it's really hard as a developer to know, 5 technologies at the same time. And, or you will have to have, 5 developers with really great social skills to communicate, and which is also hard to achieve. So this is like, I always ask if I hear such a thing, why the polyglot? Why there's even a name, polyglot programming? Because if you take a look at the JavaScript developers, right? If this were true, they would try to run Python in the backend and JavaScript in the front end. But what they are doing, they try to have JavaScript everywhere. Right, so there's no even an idea in JavaScript project to say, hey, look, we could replace backend with Python, and the question is, this is not even occurs. No, in crazy Java conferences we get such ideas, right? So
yeah, absolutely. I mean, so the funny thing, like, I don't know if you've talked to Dimitris, like, so the words like polyglot and isomorphic that come in, like, those are Greek words, and I'm sure he'd love to explain what they mean and stuff like that. But the way I see it, like, a lot of the times when we're younger, like, I speaking from personal experience, that you hear all these things from people that are very accomplished, and they're at their conferences and writing blog posts and saying, like, use the right tool for the job, or like, this is the way to go, and this will make your project fly, or whatever. And you're like, oh yeah, this is what I hear everywhere, so they have to know what they're talking about, so I'll go ahead and do it. But yeah, as you, like, mature, let's say, hopefully get more wise, you see that, there's a lot of downsides to these things that are not talked about, and it's not cool to figure them out the hard way. Like, as you said, like I'm sure for you it's probably good business, right? Because the clients come with their messes, and hopefully you fix them for them. Yeah, exactly.
First thing, but also, you can have a good business also without a mess, because the clients come over and over. We upgrade, for instance, from Quarkus to reactive or whatever, which makes sense from maintainability. So there's always enough to do, and you should not rely on the crazy projects. So this is, or I don't like. If I see no complete waste of money, this makes me a little bit sad or angry. So, okay, why you are doing all the stuff? Because at the end of the day, the outcome would be Java is not productive. Let's use Go. But the only difference is that maybe in Go or Rust or whatever, they are more reasonable and just stick with Rust, build simple code. And in Java, there were 100 frameworks with 20 platforms and and XML, YAML, and everything. Oh, YAML also good, right? In a Quarkus project, we had property file, and then they got the idea to do everything in YAML, and then they lost track, and then the entire Quarkus configuration was YAML, and they asked me, is there any tool to parse it, whatever? It's like, why you use YAML? They say, they saw in a Quarkus blog or something, they can do is YAML, and YAML is cloud native, and this was like terrible, So just stick with property file or go to database, or load a Java class or whatever, but not YAML. Why are you doing this, right? Yeah, and this is also the YAML full configuration.
I hate YAML. Yeah, I really do. I really do.
Oh, okay. So we are. Meanwhile, I can write it more or less, but I don't get the point. So I have to say, I could do this, but ask why. And someone says, "Is this nicer?" I don't get it, because nicer is objective or subjective, actually.
Subjective.
Yeah, subjective, not objective. And maybe, but not for me. Okay. So, okay, you left the company as well, I assume. Yeah, you had to, right?
So after 3.5 years, so basically what happened is that I was very lucky with this to get to Red Hat, because, like, what happened basically is I saw a tweet from someone at Pivotal at this point, so an employee working on Spring, who had retweeted a job opening at Red Hat for Spring stuff at Red Hat, and he was like, "Oh wow, now Red Hat is doing Spring. How great Spring has taken over the world!" Right? Which was true in a sense. So I saw that, and I'm like, "Oh yeah, cool. I'll apply," because I knew Spring, and at that time the job was also asking for, like, Kubernetes skills, which I had because we were also doing DevOps. So we owned all the stuff we ran. So I knew a lot of Kubernetes at that point as well. So I'm like, I apply, and cool, I get the job. So I'm now at Red Hat. So this is 2018. Starting, like, our mandate, let's say, was to make it easier for customers that use Spring to run on OpenShift, which OpenShift was Red Hat's enterprise distribution of Kubernetes. So that's how I got to Red Hat. So at that point, then I switched to, like, all Java. Like, there's no JS, no Groovy or Kotlin that I had been doing before as well. And I'm doing a lot of Spring related stuff. So this is 2018, right? But what happens very interestingly is that Quarkus was announced internally, right? So this was not a public release. This was an internal inside Red Hat that we have this new framework that was not called Quarkus at this point. It was called something else. And you know what?
This is how it was called. Yeah. How it was called? Do you remember?
It was called Protean. Protean, and I think there. If you search for Protean inside like our GitHub repo, I'm sure there are probably a few references left. And of course, if you go to the Git history, then it's all Protean. So this is I think like Christmas of 2018. So I'm about here at the company, and they released this little thing, and I'm like, wow, this is amazing. I thought this was like amazing work. That really made a difference in the Java ecosystem, right? Because at that point, like everything was Spring. The Microdot had just come out a few months ago, but what I saw was like this thing had huge potential. But obviously it was something new, right? So it had a lot of rough edges. There was a ton of stuff to be done. So I just started working on that, like on my own time, right? So our team at that point was not doing Quarkus stuff, but I was like on my own time working on it, like adding Spring stuff to Quarkus, because at that point I had a lot of Spring, like years of Spring experience. So basically, but when Quarkus was released to the public, which was I think March 2019 or April, I can't remember for sure. Then I was already like contributing enough to Quarkus to be like not exactly part of the team at that point, but at least be considered among the people that help out with it, right?
So you built the Spring DI layer on Quarkus?
Yeah, so that's the initial thing that I did. That's the initial like bigger thing that I did was all the Spring stuff. So Spring dependency injection, the Spring web stuff, the Spring data JPA stuff. That's the initial stuff I did. That's what like really got me attention, let's say, from the Quarkus team. I was really lucky. I was fortunate enough because like I knew a lot of Spring. I was curious enough to see how Quarkus works, right? So I had gone like very deep into decompiling the generated bytecode, stuff like that, to see how everything worked. So I was in a good position to be able to bring like a lot of Spring knowledge to Quarkus, right? So I was able to do a lot of stuff, and like I love different other like small bug fixes and stuff like that. So I was like gradually like contributing more and more. But I mean, I was Spring stuff was initially like the important stuff that I did. Yeah.
Interesting enough, I think the Vodafone project, there was also Vodafone Greece, right? Which ported from Spring to Quarkus, and I think you made it possible then with the extensions, right?
So here's the story about that. They didn't actually use the Spring, or at least I think tried it. It worked. The Spring thing worked for them, but what they decided to choose, I think, that you know what, if we're gonna bet on Quarkus, let's go and actually use Quarkus native APIs, right? So they switched to then like use JAX-RS and stuff like that. But they made a big bet because like they saw our presentation at Vox Days Athens in like mid 2019 or something like that. So Quarkus is like super new at this point, right? It was not proven at an enterprise scale or anything like that. But they made a bet because they were building this new stuff. They didn't want to use Spring because like Spring was at that point it was getting very bloated. They had experience with Node.js, so they wanted something more nimble. They were actually thinking Vertex, but then they understood that like from a business point of view, it's a lot easier to write Quarkus than Vertex. So they made a big bet on on Quarkus. And when COVID hit, so they had a huge spike in traffic because like they were running all these like campaigns.
This is the story, okay.
Yeah, so they were running a bunch of campaigns, and then they were seeing their Spring applications couldn't handle the load on Kubernetes. because they were making like really small pods, like with 100 megabytes of RAM and stuff like that. But then when they switched to Quarkus, like, everything just like went so much smoother, and that was a huge win for us, basically, because we actually saw that people could use their Spring knowledge, rewrite something in Quarkus fairly easily, right? So it's like a matter of days, and run it in production and see like so much better results than what they had.
So what was the improvement? Do you remember roughly, without any?
Roughly. So the I think they ended up using like 60% of the total RAM versus the Spring application. So not just heap, I mean like total RSS usage of the process. I think it was like 60, and then I think the startup time went in some cases, I think it went down like from like 20 seconds to 2 or 3 seconds or something like that.
Wow.
It was like huge, improvements that we didn't even expect, right? But the thing we saw is that with the larger the application in Spring, the more the slowdown, and to make that even worse in Kubernetes, the more you compact things in terms of CPU and RAM, then it just got so much slower with Spring. And so we saw what those folks did, and it was a win-win. I mean, it was a win for them because they actually like got their stuff in production running properly, and it was a win for us because you have a very big organization doing this important work that they could say just worked. So that was great for us. Yeah.
So it's interesting why I'm asking the question, because I have basically no Spring experience. So I stick with the Java Jakarta microprofile stack the entire time. But what I did, I modernized project back then. What do you explain? Something was slow and bloated. So we removed, everything which was not necessary. And then, we use mostly Glassfish or Whitefly. And Whitefly, Glassfish, or JBoss, whatever, OpenLiberty, they started basically 5 to 10 seconds. So this is what I remember. Glassfish was 3 seconds, and maybe a little bit slower. And if Quarkus came out, I was absolutely not interested because I thought there was the Thorntail project, and which was like a little smaller Whitefly. And I say, okay, if something is even a little bit smaller than Thorntail, I don't have any problems with Whitefly if the project is reasonable. But then I took a look at Quarkus by accident. This was like a very early version, and saw how it actually works. That it basically deploys at build time, and then I thought this is genius. So this is something I saw. I never saw that coming. I was completely surprised by the idea that you can shift the dynamic behavior at runtime to how to call it, to shift all the preparation to build time, and at runtime you just ship hard-coded stuff basically, which is crazy fast. So I wrote, I think, the very first article in Germany about Quarkus. They asked me to do so, and did lots of things. I said, okay, this is the way to go. And the funny story is now, I had the Java E code, right? And Quarkus, all my clients had it. And Quarkus was 80-90% compatible. I mean, to migrate stateless to request transactional. I mean, this is request scope transactional is not a big deal. So I could go to a project and say, hey, if you would like to have a little bit save some memory or whatever, we can go Quarkus. And I recorded a podcast with. This is already out there with a Swiss insurance company, and they had Whitefly. And they asked me, what to do, what is the future? And I say, go to use Quarkus, and they reported similar stuff. So they have OpenShift, and they could halve the size of memory, which is huge saving for the operating center, for the company hardware-wise. And startup time was not that critical because in enterprise, it is just more static. It's not like they have, to dynamically scale up and down. It runs all the time. But I was also amazed by the difference. And another story, WJAX conference. It was autumn last year. I had something on stage with Quarkus, and people came to me and said, "Hey, what is the new stuff you're doing here?" It's like, this stuff I'm showing you. This is the oldest 20 years old. The code is 20 years old, but the Quarkus. It's like where we can get the projects. And I asked them why. What are you doing now? And they told me Spring, but it's very bloated. And I hear this bloated in Spring over and over again. But what surprised really me, because back then I used the application servers, And I always had the argument, Spring is small and nimble. And now suddenly, Spring is bloated, or something happened in between, because I didn't use Spring back then, and I don't use Spring right now because it just occurred. There's enough, non-Spring Java projects, and I have so much to do that I cannot just learn Spring. Also Node.js. I just played with this, on my local machine, but never in production. So this is interesting, and also I don't think Spring does the same optimization as Quarkus does. That they build everything in advance, right? So the most similar runtime is Micronode, which I got also asked last week on my YouTube channel. They say, okay, is Spring competition to Quarkus? There was a presentation or a screencast I recorded, and my answer was, I would see more Micronode as a competitor because it's similar optimization, and Spring I would compare more to WebSphere Whitefly, how it operates, with the interceptors and dynamic behavior, right? So this is my take on it.
Yeah, so that is that I would say that is very true, right? So absolutely, the best comparison to Quarkus is Micronode for sure, right? Like the detail, how they do stuff is very different, but at the end, the big idea is the same. The big idea is that you do as much as you can at build time, right? That's the big idea for sure. What I see, like to get back to your point of how like a Spring became bloated or at least perceived as bloated, what I see it is that when Spring Boot came out in 2014, I think, or 2015, with the single like executable jar, I think that was like a very, very big change, and people loved it, right? Because that's what they were seeing in Node.js, right? You just execute it. So they took the idea from Drop Wizard, made it a lot more configuration friendly, and did a lot more stuff, and it just worked in Spring amazingly. So I was and am a big fan of Spring, absolutely. So I think what Spring Boot did in 2014-15 was excellent, like super good idea, and the result was, though, the way I see it, is that it took such a big share of the market that it made Spring, let's say, it quote unquote complacent, right? So they didn't have the need to optimize, let's say, as much because they were already being used by everybody. That's the way I see it, right? So, but then like we came around in Micronode, same idea, and we're like, there are real problems with this, right? So if you run this like in constrained environments, or environments that you actually do care about how much runtime footprint you have, then this is a problem, right? So we rethought stuff and came up with very similar programming models. Like I said, programming models like the same as Jakarta E stuff people have been using for a long time. Similar ideas in Spring, because let's face it, like Spring and Jakarta have been influencing each other for a long time. So philosophy is the same, but it's just in a much smaller package, right? So, yeah, I think it really makes a difference.
Okay, perfect. So, what are you working right now on?
Yeah, so lately, so like I still do like plenty of stuff in Quarkus core. So like the previous like very important thing we did with a few colleagues was like the REST layer. We rewrote like the REST Easy project. Basically, we called it REST Reactive. Now we're calling it Quarkus REST. So anyway, that was like the moving all the build time stuff for the REST layer, which again made a difference, and we had a lot of improvements there. That was a few years ago, but now like the big focus for me now is this LangChain4j stuff. So
very good. George, this is now the cliffhanger. We need 2 more episodes. So what I'm interested in, REST Easy, Classic, or Reactive. So this we have to talk in depth because there's lots of confusion. Reactive, virtual threads. This would be one show, just virtual threads and reactive. And then one show about the amazing LangChain4j, because this is the big future. And for you, a homework, are you aware of Llama4j or Llama2j?
Yeah, I've seen it, yes.
Alfonso? So what he also works on LangChain4j, he's able to integrate Llama model with 1,000 lines of code of Java without nothing between. and LangChain4j with that. And he says it would be even GraalVM compilable. The only problem is this the vector API. There are view operations which are not. So this is the problem. And the next big thing is there's a JVector pure Java database for embeddings. So what we can achieve soon with Quarkus and LangChain, full stack, production ready AI for enterprise.
Absolutely.
So without any GNI or whatever, and this Llama right now is 10% slower than C without GPU. And he's working on Tornado VM. So if they can talk to GPUs with Tornado VM, it will be actually faster than C and way faster than Python. So I would say that, and this is what one guy working on it, So this is like a big thing. So I would say LangChain4j, Quarkus, this Llama 4j Llama 2j. This is not 4j, Llama 2j, and this is and Llama happens to be like the API for lots of open source models like Mistral and stuff like that. Yeah. So I think this is a big thing you're working on. So I think this LangChain4j or Quarkus could be as revolutionary as Quarkus itself. I would say it's a big thing.
I hope so. Yeah.
I mean,
we see a big future. Like you said, things will only get better. I mean, I'm not actively working on the inference stuff that you mentioned, but with the new Java vector stuff and the Babylon stuff,
exactly.
out, I absolutely believe that you will be able to run inference with Java, or native Java, and not any of the other stuff. And then once you can do that, I mean, the possibilities here are endless, right? Because if you have like the LangChain and Quarkus layer for the user experience, and then you have all the inference stuff running in Java, which you can optimize, then you can integrate tightly or whatever.
And this will come because one of the most requests from enterprise is how to integrate LLMs, AI, or Gen AI with existing enterprise apps.
Exactly. Yes.
And this is exactly what you did in the year 2000. So back then, the companies had, the algorithms in C, Pascal, whatever. And the question is, now we have Java, how to integrate, with the old stuff. The integration projects were big. And for me, the AI or Gen AI is very similar to the old systems back then because some of the models are Python, whatever. So it's as ugly as SAP or whatever was, 20 years ago. So I would say the same challenge. And if we can do this with pure Java, everything is suddenly solved. We can control the concurrency. There is no GNI, no memory leaks, no inconsistencies, or really big thing. Okay.
Absolutely.
Thank you.
Absolutely. So I just want to add a small quote before, basically saying exactly what you said. A friend of mine and a colleague, Ioannis Carnelos, who also works on Quarkus, he said exactly what you said. He said that what we're doing now is turning the AI problem in Java into an integration problem, right? So all you need to do is take care of the proper integration, and like you said, the magic will happen.
Yeah, perfect. Where people can find you on the internet, what are the references to whatever you like, to your Twitter, whatever you have, Quarkus project, what do you like to promote?
Yeah, so Quarkus obviously is quarkus.io, and that's where our website obviously is Quarkus.io/Quarkus is the repository for the main repo. My Twitter is GEOAND86. And GEOAND for GitHub.
I'll put it in the show notes as well, so that there will be reference. Cool. But yeah, exactly. Perfect.
Cool.
See you soon next time and the next episode with Reactive.
Awesome. Thank you so much for your time.